I definitely want to thank Ron and the Angel Beat team, as well as Corbin and OneSource for inviting us to participate here. My name is Walid Ismail, and I'm from Go Electric. For today, I'll be talking about who Go Electric is as a company. I'll take a quick look at microgrids by defining them at a high level. I will discuss the type of solutions that we offer at Go Electric, and then discuss again in minute details kind of our approach to microgrids from a controls architecture and how we have the brains to conduct the operations or the sequence of operation in microgrids. And I'll finish off with a couple of case studies. Just tell you a little bit about myself. My name is Walid Ismail. I'm a regional sales manager at Go Electric, which is a SAFT company, and I am based in San Francisco, California. I was actually born and raised in Lebanon, where I completed I got my French baccalaureate, and then eventually moved to the States to go to school at UCLA. I ended up liking it so much that I came back about 10 years later to get my MBA. So I'm a double Bruin, and I'm very proud of it. What I do in my free time, I love to play tennis and soccer. I'm very competitive. I play in a couple of leagues locally, and I can't wait to be able to go back and travel, hopefully in the next couple of months as things unfold on a global landscape. So who is Go Electric? We got founded back in 2011 in Anderson, Indiana, where we still have our main facility for manufacturing. I actually come from the SAFT side of the business, which ended up acquiring Go Electric. SAFT, namely, is an electrochemistry company that makes any kind of battery under the sun. And I was mainly in charge of their utility scale in front of the meter business. But since then, at Go Electric, I moved over to the behind the meter microgrid space. Since we got acquired, we became part of the Total family of companies, and Total Energies being the fourth largest energy company in the world. That says a lot about having a backing from a very sturdy balance sheet, as well as their efforts to go into carbon neutrality, which we've been talking about a lot from the previous panelists today. We are very proud to say that we are considered to be the center of microgrid excellence globally for Total. And just to start off, high level, what is a microgrid? I know that term is being tossed a lot nowadays. So as you can see depicted here in the example, a microgrid is in essence a group of interconnected loads and some distributed energy resources, or DERs. Those namely tend to be solar, wind, some type of generation asset, mainly a genset, as well as a battery energy storage system. Now, if you talked to me last year, I would say there was probably more microgrid conferences than microgrids out there. But thanks to a lot of new incentives and the market moving forward towards resiliency, microgrids will be popping up more and more in the future. Now, whether it's to alleviate, the intricacies of having renewables on the grid that will eventually cause irregularities, or if it's to keep your lights up during a storm, a battery-enabled microgrid system will be necessary, and you're definitely going to see these, again, become more prevalent in today's society. Some of the trends we've seen, specifically to have resiliency and uninterruptible power supply, are going to be coming up in these commercial industrial space. For instance, in the manufacturing processes or data centers, we have really a critical load that you cannot afford to live without during an outage. So microgrids come in very handy because they can operate by being grid tied. But on top of that, as you can see here in that little disconnect here, microgrids have the ability to completely disconnect and run in islanded mode as a an autonomous / independent energy entity away from the grid. We can also see microgrids in the public sector coming up, mainly in universities, government buildings, as well as emergency centers. And obviously you have the off-grid scenarios, which are already, to start with, completely disconnected from the grid, mainly on islands. And that's kind of where we've seen a big boom, where entities are really looking to go away from green emissions and go into retiring the diesel gensets and mainly using a new portfolio of renewable energy. Now, let's dive a bit deeper into kind of the battery-enabled microgrid value propositions. With the battery, as was previously mentioned in the discussion prior to mine, batteries tend to have a lot of value add, where in the grid-tied services sense of things, they are allowing you to have peak shaving, demand management, ancillary services, whether that would be frequency regulation or voltage regulation. But the biggest thing to mention here is, because in the microgrid sense, we are talking about resiliency. We are talking about this independence from your grid. And that is whether you want to charge at cheap times and then discharge at later times, another thing that really comes into play is being able to run independent during any kind of storm or outage event. And this is where resiliency comes into play. In that note, we are actually maximizing the use of DERs because you're definitely using your solar, your wind, and charging the battery as much as you can to relieve stress on the grid and run in islanded mode as much as possible. Another thing definitely worth noting here is the economic dispatch models. That's kind of on a higher layer of controls, where in the cloud, based on AI algorithms, we can work with companies such as Energy Toolbase that will allow the end user to have extra revenue streams by doing demand management programs or tariff management in the sense of economic dispatch models. So not only will you be incurring savings by running a microgrid, but you can also have extra revenue streams, which ultimately will lead to a better return on investment for your project. Just to give you a quick picture about microgrids, they are very dynamic and in a way they are kind of complex and cumbersome. One thing that I would like to show here is the amount of complexity from different vendors and different pieces of equipment that make up a microgrid. There's definitely going to be some integration processes to go through and different vendors to talk to, but the toughest thing is also finding out, the warranty. Who are you going to talk to back up the warranty? And that's when Go Electric comes in. That's what we're trying to solve. We are providing a turnkey solution, kind of an all-in-one plug-and-play microgrid in a box, where we are eliminating and reducing the soft costs associated with your civil electrical work, installation, integrating. And in essence, we will be providing the same use cases and value, but in kind of an all-in-one solution. What we make in-house in Indiana is this power conversion system that also houses the microgrid controls. Microgrid controls tend to be the centralized brain of the operation, what dictates eventually when to charge, discharge, run solar, disconnect from the grid without any backfeeding. So all of this is controlled pretty much from our box. When it comes to the battery energy storage system, we are fairly agnostic, even though we are a SAFT company. We don't have to use SAFT as a battery provider. It depends if the customer has their own preference. All we have to do is integrate with the BMS of a different battery. We've done so with Powin, which is one of the biggest names in the industry. We also work with EnergyPort, who integrates CATL or Goshen cells. So when it comes to us, we like to provide a full plug-and-play solution with the battery. And we obviously will wrap the whole warranty under our roof. So everything that needs warranty and maintenance or even performance guarantees, we will be able to cover that. Taking a step back before we kind of get into the salesy approach, what we do at a first step is really a consultative approach to microgrid design, because again, microgrids are very dynamic and differ from one site to another. What we do is we will discuss with the customers, whether it be a developer, utility, an energy procurement or construction company, early on in the phase to look at the loads, the single line diagrams, what are the use cases you're looking to accomplish, what revenue streams are you looking to have. So we can pretty much make a model to give them not only the correct sizing to benefit from this microgrid, but also the potential ROI and at what year you kind of make your money back. What we make in-house, again, is that Link Secure, which is the power conversion system I showed previously. It comes in a bunch of different flavors that I will show in the next slide. But the biggest thing we do is the microgrid controller, which is the AutoLink, and that is embedded inside of our Link Secure. On top of that, we do a lot of engineering services, which is factory assessment tests, SATs on site, as well as commissioning. But what is worth noting here in the picture, at our facility in Indiana, we have a bidirectional grid interface, and that allows us to do a hardware in the loop testing. Now, what does that mean? We can actually perform and mimic the same exact sequence of operation of your microgrid during the design phase. So you don't have to go and build and design anything until we kind of test it at our facility via some simulators that are seen in the picture. We have a battery simulators, we have a grid simulator, and we are also grid tied so we can disconnect and see how we would react during an outage. So these are kind of the different flavors of our PCSs. We have a Link 75, a 250, which tends to be the building block for larger systems that we can put in parallel up to 1.5 or 2 megawatts. Now, another thing that we do, and this is kind of what we've learned the last couple of years from the market, is we want to further reduce the soft costs associated with the installation and the complexities on site, because that ends up taking a big chunk of the project deployment. We came up with this deployable microgrid or the Link Hub. And you've already seen kind of different components. This is customizable, but what dictates the size of the system is the battery container. This is going to be a fully integrated solution with a fire suppression system, whether it be SAFT or other companies. And we also combine in the front our power conversion system, which again houses the MicroGrid controller. We can customize it to put a switch gear or maybe even an EV charger in the front. And what we're trying to do here is have again, as you can see, this can be transported on a flatbed. You drop ship it on location. It's minimal civil work. And even from a connection points perspective, it's very easy to interconnect because all the wires will be running on the bottom, and it's just you connect to the load and we're good to go. We can also customize this to be laid out on pylons to even further reduce the scope creep and also the cost associated with the installation. Now, one of the biggest value adds that we've been talking in the sense of resiliency and uninterruptible power supply, Go Electric is the market leader in this grid catching mechanism. There's really nobody in the market that does this. We have a blipless transition to islanded mode. What that means, anytime you have a critical load, again, whether it's a manufacturing plant or a last mile stop for kind of distribution center, we allow your lights to stay up and your loads to stay up pretty much during any kind of outage, whether it's a brownout or a blackout. And we do that via this grid catching mechanism. So in essence, we went to the National Renewable Energy Lab, or NREL, and connected our link secure to their facility, and they even caused a grid fault. And as you can see, the grid voltage and the current pretty much go to zero. But what happens if this was the competition? Your solar would go down, everything would pretty much go down, and you have to have a black start. Instead, with our grid catching mechanism, we are grid following the whole time. And within 80 milliseconds, so without even a flicker of a switch, we will go into a grid forming mode. And this is where we are in islanded mode. We are running independent of the grid, and we can run as autonomous as need be until the grid is back up and running. And then we just switch back to the grid and allow backfeeding there. And this is all pretty much done because of the speed of the microprocessors that we develop. Just a very quick overview of the controls architecture and how we really fit into the architecture of a microgrid. We've talked about the different DERs, or distributed energy resources, that make up kind of the microgrid. Again, we will have a battery component here that becomes the anchor resource, and we are given the controls for that anchor resource to take over the load. And the way to do that is, again, through our AutoLink microgrid controller, which acts as an EMS, or an energy management system, which in essence is the brains of the operation. This will dictate when to charge, discharge, connect and disconnect to the grid. And obviously, in the macro layer, this is something that is enticing to some developers because there are extra revenue streams that can be generated in the cloud, where we partner up with Energy Toolbase, for example. And they bring in this AI algorithm that can look at day-ahead markets and tell them when to sell back to the grid and pretty much generate future revenue streams. Some other things that we've been able to solve based on our offering is our Link Secure acts as a synchronous generator and has full 4-quadrant capabilities for kVAR control. So this is reactive and active power, whereas you have grid stability issues or maybe low power factors, we come in and can solve that via our 4-quadrant kVAR control. Another thing worth noting is most of the microgrids tend to have some kind of generation asset, and obviously we're looking to phase diesel gensets and natural gas gensets, but they tend to be kind of a backup to the backup, which is the battery nowadays. What we do whenever you have that component part of your microgrid is we allow you to run in the most optimal zone. So we optimize the genset use. And what that does is a twofold kind of benefit system. One, you're running most efficiently, meaning you have the least amount of consumption used. And that will in turn reduce your cost associated with the diesel usage, but that also will reduce the cadence of maintenance needed because you're not really using that generator anymore. It's more of a backup to the battery microgrid. One last thing before I close out here and open it up for questions, a couple of case studies worth mentioning. Maybe I can start off with the 29 Palms microgrid, where most of over there, this is with the Marines down in 29 Palms, that is very close to Joshua Tree. We provided a 150 kilowatt Link Secure with a 690 kilowatt hours battery. And what we solved there for the customer, they had some solar connected with 2 gensets, but their power factor was about minus 0.05, and they were not able to keep the solar up and running as a prime. So they had to always use the gensets, which again is polluting, is costly, and needs a lot of maintenance. So with our solution, our battery-enabled microgrid system, we allowed them to pretty much retire almost the gensets, run autonomously with our battery-enabled microgrid, and allow them to reduce the costs with the maintenance of the gensets. You can go on our website at Go Electric and you can find some more case studies to download, and I'd be more than happy to connect with you offline. So thank you all for participating, and if there are any questions, I'm more than happy to answer.